Okay, good afternoon everyone. Okay, so in this video I'm going to show you the solution using this exercise question from our last class. Okay, using naive Gaussian elimination and partial pivot elimination. Okay, so this is the equations. Okay, and then when transformed into augmented matrix, okay, it looks something like this. Okay, and then so for the first method, the naive Gaussian elimination, okay, you still remember how to do it? Okay, so what you have to do is, okay, let me just copy that. Just copy that, right? 10, -7, 0, 7, 3, 2.099, 6, 1, 5, oops, that is not negative x, so negative 1, negative 1, 5, 6. Okay, so for naive Gaussian elimination, okay, we have to form upper triangular form for this matrix. Okay, and you have to zero this first. Okay, to do that you can use this equation. So for R2, okay, minus negative 3/10, okay, R1, okay, because 3 is in the second row. Okay, 3 is in the second row. Use different pen. Is in the second row. 10 is in the first row, right? Okay, so when you cancel this out, then the element will become 0. Okay, and then for R3, you can use R3 minus 5/10 R1. Okay, so after that step, okay, this is what you will get. Sorry. Then 7, 0, 0.0010, 6, 6.0010, 2.5, 5, 2.5. Okay, so now you have to zero this one, okay, to get that upper triangular form. And for R3's transformation, okay, use R2 as your pivot equation. If not, you will risk converting this value. If you use R1, you will risk converting this into something else. Okay, so use R2. So for R3 minus 2.5 divided by negative 0.001. Okay, bracket that, times R2. Okay, so now when we use naive, okay, in this case you see this, okay, this is gonna resulted into a big value. Let me just calculate that. 2.5 divided by negative 0.001, so that is negative 2,500. Okay, so that's a big value. Okay, it can result in some errors lah in your decimal places. Okay, so let's say, okay, we go to the next, we just solve for that. Okay, so 10, negative 7, 0, 7, 0, negative 0.0010, 6, 6.0010. so this now becomes 0. This is 0 as well, so now it's 15,005, and this one is 15,000. Okay, so from this equation, okay, let's say you solve this using back substitution. Okay, when you solve for x3, you will not get 1. Okay, you will get if you use just 5 significant digits, okay, you will get 0.99967 like that. Okay, you will not get 1 because of this division with small number. Okay, so that's why when you found cases like this, it's better to use the partial pivot method. Okay, partial pivot method. So what was our equation again? Okay, this is our augmented matrix. Okay, 7 0 7 negative 3 2.0 9 6 3.901 5 negative 1 5 6. Okay, so in this method you have to compare the absolute maximum of elements in the same column. Okay, so let's say for the first column, for these 3 elements, okay, there's 10 and there's negative 3, sorry, and then there's 5. Okay, the biggest absolute value is 10. Okay, so you don't have to do any swapping. Okay, so now all you have to do is just zero these elements. Okay, make those two into 0. Okay, so for you to do that, you can use for R2, okay, use R2 minus negative 3 over 10. Okay, the same as the previous part, the previous method. R3 minus 5 over 10, R1. Okay, hold on. Okay, sorry. Okay, so where were we? Okay, that one. Okay, so now your next matrix will look something like this. 10 negative 7 0 7. So this now has become 0. So negative 0.0010 6 and 6.0010. Okay, so basically it's the same second step as in the Naïve method. Okay, 5 2.5. Okay, so for this part, this is where it differs from the first method. Okay, so now you check for the absolute maximum for these 2 elements, okay, between negative 0.001 and 2.5. Okay, so between these two, this is the bigger one, so now you have to swap this. Okay, so the next step will look something like this. 7 0 7 0 2.5 5 2.5, and then there's the last row is 0.0010 6 and 6.0010. Okay, so from this one, okay, to form an upper triangular form, just zero that out. Okay, for this R3, okay, you use R2 as your pivot equation, because if you use R1, you will risk converting this into something else. Okay, so R3 minus negative 0.0010 2.5. Okay, R2. Okay, so your matrix will look something like this. 7, 2.5, 5, 2.5. Okay, now this is 0 and this is 0 as well. So this is 6.0020. This is also 6.0020. So now when you swap between R2 and R3, you will get a better answer lah. Okay, a more round number punya answer. Okay, so when you solve for, let's say by using back substitution, okay, when you solve for x3, you will get equals to 1. Okay, when you solve for x2, you will get -1, I think, -1, and for x1 you will get 0. Okay, so now you see how these two methods can be used in different set of equations lah. Okay, that's it.